Dear ladies and gentlemen, dear fellow students, my name is Fruzsina Káldy. I have been chosen for this year's St. Georgi Pupil of Excellence, and I would like to grab this opportunity to introduce you to my journey through science in the last few years. When Bruce Beutler visited us in 2023, in his lecture, he spoke about how one really can't and really shouldn't separate natural sciences into distinctive fields such as physics, chemistry, or biology. Because research isn't about these separate fields. It's about observing nature thoroughly and asking great questions, which will eventually lead to complex and multidisciplinary problems. But before the big discoveries happen, even the most celebrated scientists start somewhere. For instance, Shechtman eagerly talked about how he took part at a science fair event at a fairly young age, which made a great impact on him. To acquire the skills that are needed for solving complex scientific problems, one needs to start with something seemingly simple and easy. But if we take a deep dive into even the simplest scientific problem, we will see that it leads the way to complexity. In the National Academy of Sciences Education's program, you have also experienced how the different skills were improved as we did countless laboratory practices, attended to lectures, and took on the challenge to ask relevant questions afterwards. Not only could we learn about the laboratory techniques, but we could get a taste of what it's like being a researcher and planning our own experiments. And yet, we are on our way to infinity and beyond. With these skills in possession, one will be able to take on scientific problems with joy and success. I would like to illustrate how I utilized this skill set of mine at the 7th International Chemistry Tournament. The International Chemistry Tournament differs from the other scientific Olympiads. It is a team-against-team international competition with 12 open-ended problems regarding mostly chemistry, but questions regarding physics and biology are also present. The nature of it is much like a research project. One encounters a problem, teams up with others, and tries their best to find an appropriate solution. Finishing the scientific work, the solution must withstand a well-constructed scientific debate between the teams of the different nations. The problems at the tournament were versatile. For instance, one problem was concerned with the reduction of methane emission of wetlands. One revolved around the design of a complex, which contains one metal ion from each block of the periodic table. And there were also country-specific problems, such as problem number 8, keeping tortillas safe from frying. An original idea and a great deal of creativity are key factors of success here. Despite some solutions staying theoretical, the overall process of proposing the theory requires a unique way of thinking, which can be used as the fundament of a future researcher's mentality. Owing to the nature of the tournament, the scientific communication and voicing the relevant concerns about the different solutions are also of great importance. Keeping tortillas safe from frying revolved around the center question: how can one bake something without high temperature? As I went deeper in the topic, more and more questions arose, and soon a complex problem was standing before me, waiting for me to solve it. The task was to propose the best catalyst of the Maillard reaction when making tortillas, to obtain an edible product by avoiding the use of oil and high temperature, while maintaining the nutritional value of the final product as intact as possible. I began the work by thoroughly screening the available literature regarding the Maillard reaction in order to learn about its nature. The Maillard reaction occurs between the free carbonyl group of reducing sugars and the free amino group of amino acids, resulting in volatile aroma components and brown pigment molecules called melanoidins. The Maillard reaction proceeds as follows. It is initiated by the condensation of the reagents, then an intramolecular rearrangement, the so-called Amadori rearrangement, takes place. Based on the pH of the environment, it will take on different reaction routes, which result in reactive intermediaries. Many subsequent reactions occur, and the end products of the cascade are the aroma compounds and the melanoidins responsible for the organoleptic properties of the food. For the catalysis to be the most effective, I decided to find the rate-determining step of the reaction. Based on literary data, the rate-determining step of the Maillard cascade is the amidary rearrangement. Therefore, I have been focusing on this reaction in my solution. The amidary rearrangement takes place after the nucleophilic attack of a free amino group on an aldose. After the subsequent dehydration, an imine, the so-called shift base, is formed. Then the pi bond shifts towards the sugar moiety, resulting in a 1,2 enol, which then undergoes tautomerization, and this process results our final product, the 1-amino 1-deoxy 2-ketose molecule. Now that I have chosen the desired reaction, I face multiple problems. The amidary rearrangement is catalyzed by Lewis acid, so it is preferable to find an appropriate one to perform the catalysis. The effectiveness of the catalyst should be sufficient even at lower concentration. And because I'm working with tortillas, I also need to consider food safety, because even if the catalyst is eliminated after the reaction, some residues may stay in the food. I also need to consider the specificity of the catalyst on the amidary rearrangement, because it is disadvantageous if the catalyst represses any other following reactions. During my literature search regarding these aspects, I chose zinc 2 ion as the best catalyst. The Lewis acid characteristic of the zinc 2 ion facilitates the amidary rearrangement by forming a complex with the shift base. After the condensation of the reagents, the shift base formation occurs, which is followed by the complexation of the zinc 2 ion. Due to the electron pool exerted by the ion, the zinc imine complex undergoes a transformation to a zinc amine complex, and the following elimination of the zinc 2 ion is followed by the thermodynamically favored keto-enol tautomerization. And this process results our final product, which can close into the cyclic form. My favorite part of solving this problem was the experimental part. Based on the described mechanisms and previously conducted experiments, I decided to plan my own set of experiments in order to demonstrate the positive effect of zinc 2 ions on the rate of the reaction. Implementation of the zinc catalyst would happen using zinc acetate as the zinc source incorporated in the tortilla dough. After the catalysis, a precautionary purification step would take place, with vitamin B6 being the chelating agent. To finish up the production process, a lyophilization step would be next in order to set the final water content of the tortilla and achieve an overall better texture for the final product. I performed demonstrative experiments on a model tortilla dough to try to determine the ideal concentration of the catalyst. I experimented with 4 different concentrations, and I incubated the tortillas on 50 degrees Celsius. On total, I conducted these experiments for 4 hours. Here on this slide, you can see 100 milligrams of samples suspended in 3 milliliters of distilled water, laid out as follows. The reference sample was baked golden brown using a heat gun, and samples were taken after 1, 2, and 4 hours into the experiment. On the right side of the slide, you can see the 100 milligrams per liter zinc 2 ion model dough compared to the control model dough. Obviously, every model has its own limits, and this could be further improved in order for the color to be enhanced more. But doing these experiments really had me learn a lot about the nature of science in action. Based on literature findings and these demonstrative experiments, I reckoned that 100 milligrams per liter zinc 2 ion concentration would be ideal to perform the catalysis. Without any further purification step, on a daily basis, roughly 2 bags of chips would be safe to consume. Further into the production process, a precautionary purification step would be next. Vitamin B6 is used as a water-soluble and food safety-appropriate chelating agent. Including this step in the production process would result in an increase in consumability of roughly 7 bags per day. The final step of our production process is the lyophilization. First, the tortilla would be frozen, then the pressure would be lowered in order for the ice to sublimate, and during the secondary drying, by elevating the temperature, the final water content of the tortilla would be set. Proposing this solution still holds unopened doors and the rising questions that still need to be answered. How can we further improve the effect of zinc 2 ions? Are there any reactions that are, for instance, beneficially catalyzed? There are techniques in the food industry, such as high-intensity ultrasound treatment, which can have a positive effect on the course of the reaction. What would be the exact effect of it? These are just some of the questions that maybe someday will be answered. And also an important lesson from the tournament, proper citation is key in the scientific community. The tournament has been an important step in my life. It gave me a different perspective. One of the most important take-home messages has been the importance of teamwork. Understanding the complexity of science clearly requires many different perspectives, and teaming up with others can make several different worlds and aspects collide. I learned what it's like to be a member of a team that can work in unity. These are skills that are inevitably needed for one to be confident in the scientific life. Whether it's about tortillas or cancer research, every problem originates from an observation. With curiosity and a bit of creativity, soon a question will form. Even if there's an answer, more and more questions will arise. In that chaos, one needs to be able to make an order, to define the problem itself, which will lead to, well, even more questions. I got a taste of what it's like being on a pathway to a solution, and solving this problem regarding baking and tortillas has helped me to become a better problem solver. This experience did not only improve my problem-solving thinking, but I got to see another aspect of it, what it's like coming up with one. We had the opportunity to represent our school and the National Academy of Sciences Education in Budapest, and we did a project regarding cancerous cells and contact inhibition. As a part of this project, with my schoolmate, we have written 2 tests which I invite you to solve. Writing these tests have helped us deepen our understanding on the topic of contact inhibition and urged us to learn more. I invite you to solve this test by scanning this QR code. Lastly, I would like to speak to my fellow students here. I hope by fleshing up a part of my journey on acquiring skills from around the scientific world, I could encourage you to be bold and view things differently than before. The curiosity that lies within us is capable of great things, so never stop asking questions and never stop looking for the answers. I would like to spare a moment to express my gratitude towards my teammates and the Hungarian organizers for their dedicated work and support towards me. And also, I would like to express my gratitude towards the 2 people who have encouraged me to push myself to my limits. Your dedicated work got me through these years with success, and during these times, I could rely on your presence and your endless support, which really meant a lot to me. So, thank you very much. Dear ladies and gentlemen, it's been an honor to stand here, and I would like to thank you for your attention.
Dear Fruzsina, that was amazing, that was fantastic. Thank you very much for your dedicated work. And we also would, as I mentioned in my presentation, the real heroes, as you mentioned, your mentors as well. So I would like to ask also to come up to the stage, Bence Farkas Szabó, and I also would like to ask József Baranyai as well to come up to the stage. Please, József, I know you also, please come up. I know that your work and both of you to take the prize.